With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
Hello. So question is saying that the half-life of strontium 90, right? So this is strontium, right? So this is strontium 90. So actually this is like this, strontium here, and this is 90, right? So this is strontium 90, right? So this half-life is 6.93 years, right? So in a child body, the 1 gram of strontium 19 doped in a place of calcium, right? So how many years will it take to reduce its concentration by 90%, right? So assume no involvement of strontium in metabolism, right? So we have to find out the times, right? So how many times, or you can say how many years will it take to reduce its concentration by 90%, right? So as you can see here, this is the strontium 90 is a radioactive isotope. That means, and we know that all the radioactive decay are of first order, right? So that means this is actually a reaction of first order reaction, right? So this is actually a reaction of first order, and for the first order we have the formula, right? So we know that the rate constant K is equals to 2.303, that is 2.303 divided by T log, right? And this is initial concentration A, and this is A minus X, right? So this is remaining concentration, right? So A minus X is our remaining concentration, right? So now we have to find out this time, right? So here you can see this, the half-life for this strontium 19 is 6.93. That means the half-life for this will be half-life. Let's say this is half-life will be, you can say here, it is T half, right? This can be written as T half or T50, right? So you can write in whatever way, right? So this is T half or T50, right? So this is given here, it is 6.93 years, right? So this is given here 6.93 year, right? So now you can see here, we have to find out the how many years it will take to reduce. That means we have to find when its concentration by 90%. That means we have to find here T90, right? So we have to find here the T90, right? So now for solving this, we have to use this formula, right? So we know that for T half reaction, right? So you can see here the T half. So the time for T half will be equals to you can see here 2.303 divided by K, right? And here log A, right? So as we know that this is concentration is given here 90%, right? So we can assume that here the initial concentration would be you can say that initial concentration would be 100, and the remaining concentration here, you can say, if I talk about T50, that means the value of X here becomes 50, right? So the value of X here becomes 50, right? So in this way, I can say this becomes 100 minus 50, right? So this is our remaining concentration, right? So if I solve it, so it becomes T50 is equals to 2.303 divided by K log, right? 100 by 50, right? 100 by 50, right? So you can see here, this, let's say this is our equation first, right? So let's say this is our equation first, right? So now if you solve it for T90, right? So if you solve it for T90, that means I can solve it for T90, right? So for T90, you can see here the equation becomes 2.303 divided by K, right? Log, right? So this is log our initial concentration is 100, right? And for 90% of reaction is completed, that means we have remaining concentration is 10, because here the A minus X becomes factor 10, right? So here it is said that the concentration by 90%, that means 90% of the reaction is completed and the remaining concentration is 10%. That means the value of X will be 10, right? So now you can write here that is 100 minus 10, right? So this will be 100 minus 10, right? So here this equation becomes, you can see here, so the equation becomes T90 here, which is equals to 2.303 divided by K, right? Log 100 by 10, right? So now you can see here, let's say this is equation 2, right? So now you can see here, if I divide the equation 1 by 2, right? So if let's say I write here, divide equation 1 by equation 2, we get, right? So what will we get? So you can see here T50, right? So that is T50 here, right? So this is T50, right? So I can write here as T50, right? So this is T50 divided by T90, right? And this is equals to 2.303 divided by K, right? And it becomes here log 100 by 50, right? So you can see here this will be equal to 2, 100 by 50 will be equal to 2, right? So you can write here as this will be equal to 2, right? And here this is also you can say that 2.303 divided by k, and this is log, right? So this is log, and 100 by 10, that's equals to 10, right? So now you can see here, from this factor to this factor cancel out, and you can say that the value of log 10 would be equals to 1. So you can see here the T50, right? So the T50 divided by T10, not T10, T50 divided by T90 will be equals to log 2, right? So will be equals to log 2, because log 10 value is equals to 1, right? So there is no need to write it, right? So now we have given the half life for this strontium is 6.93 years, right? So it is given here 6.93 years, right? So now you have to find this T90% reaction complete, right? So time required for 90%, right? So now you can calculate it, right? So you can calculate it, right, just by putting the value of log 2, right? So you can see here the value of log 2 will be, you can see here that 6 point, right? You can see here that is 6.93 year divided by here, you can see here this is T90, right? And this would be equal to 0.3010. This is the value of log 2, right? So now you can calculate it. The T90 would be equal to 6.93 year multiply by, not multiply by, it would be divided by, right? So this is divided by 3010, right? So the value of this calculation, right? So this will be equals to T90 would be equals to 23.03 years, right? So 23.03 years, right? So this is the time required for 90% of the reaction, right? So now let's check our option, right? So our options are A 23.03 and option B here. So you can see here, you can easily answer this question. So the correct answer will be 23.03, right? So because we have got this answer in our calculation, that is 23.03, right? So in this way I can say this, the option B, C and D will be the wrong answer, and we are left with the correct answer, that is option A, right? So hope this answered your question. So thank you.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut app today.